Hello, this is Anil Kothari. I'm going to introduce P block elements in front of you. Let us see at first the introduction of P block elements in class 12th. We mostly discuss only these four blocks, four groups: nitrogen family, oxygen family, halogens family, noble gas family. Generally, the nitrogen family is known as nicogens, which are responsible for suffocation in organism. These are life-giving elements. These are halogens, mostly obtained from the sea or a rock, and these are noble gases. At first, initially, these was named as inert gases, but after Bartlett, who found that xenon at particular temperature and pressure condition, it reacts, so by they are also known as noble gases, which is appropriate name for these elements. Now we have this nitrogen in atmosphere by volume 78%, and phosphorus found as apatite family, and these have very less abundant in the nature. Okay, now nitrogen is also found as chili saltpeter, having the formula NaNO3, and Indian saltpeter KNO3. And we have phosphorus as apatite family, and apatite families are fluorapatite, chloroapatite, hydroxyapatite, having the formula Ca3PO4 twice CaF2, chloroapatite Ca3PO4 twice CaCl2, hydroxyapatite Ca3PO4 twice CaOH twice. Now, trick for learning these elements: if you want to learn the nitrogen family, then we have the trick NiFo-RnB, nitrogen, phosphorus, arsenic, antimony, bismuth. And if you want to learn the oxygen family, then we have old style CTPO, oxygen, sulfur, selenium, tellurium, polonium. And if you want to learn the fluorine, chlorine, bromine, iodine, astatine at a trick, then we will call it Firkal Bharayanti. And if you want to learn the halogen noble gases family, then we have a HENA or Carinaga X-ray Rangin, which stands for the HENA: helium, neon, argon, krypton, xenon. And here we have the formula: atomic number helium have 2, and neon has 10, and argon 18. Now krypton, it's a table, 18 to the 36. Now krypton, then argon, krypton, xenon, then having formula 54, 18 to the 36, 3s are 54, and radon. If we add 54, 332, then we get 86. Then we have radon, the atomic number 86. Now we go to the trains in atomic properties: electronegativity. As we go from top to bottom, decreases the electronegativity, and approx nitrogen has a different electronegativity which is higher than other family members, which is responsible, it's a hydrogen bonding, and other family members have the electronegativity similar to the hydrogen, that is why they do not form hydrogen bonding. And a similar trend is found in the atomic and ionic radii, and a similar trend is found in ionization enthalpy. That mean, as we go from top to bottom, then ionization and enthalpy or atomic radii or ionic radii, atomic and ionic radii, as we go from top to bottom, same as electronegativity but in reverse order. Means its reverse is found here. And if we discuss ionization enthalpy, then it decreases from top to bottom. Okay, atomic and ionic radii increases from top to bottom. And if we discuss the metallic character, nitrogen and phosphorus are non-metals which have the high tendency to accept the electrons, and these are arsenic and antimony, which act as a metalloids and having the characters of non-metals and metals also. Bismuth has a high tendency to give the electrons, that is why they are known as this is known as metal. Now in 12th class, board related questions are, generally we see the paper having the question, give the structure of XeF6, give the structure of Xe uh, F4, like such structures are found in the question paper. And we have the questions which are based on the anomalous behavior of the nitrogen, oxygen and fluorine, which generally have the high electronegativity in a smaller size in their family. Now we have mostly the questions from the interhalogen compounds, why they are inactive compared to the halogens, and a reducing character of hydrides of the family. Now most of the time Haber process and contact process is discussed, and sometimes we get the question as red, differentiate the red, white and black phosphorus, which is the highly reactive form of the phosphorus. Then we will call white phosphorus is highly reactive form. Mostly in ancient movies we see that some persons rub the matchsticks on a head. They react very fast and matchstick burn got get burned. That is why, because white phosphorus is highly reactive form. Nowadays we use the red phosphorus as a matchstick. Then most of the questions are based on the inert peer effect of the p block elements, which are mostly inert peer effect means the members of the family like bismuth, polonium, astatine, antimony, tellurium, iodine. These form the compounds having the high stable lower oxidation state. This is the inert peer effect. Now we have the questions reactivity of interhalogen compounds. Most of the time we get the question from this topic, why the interhalogen compounds are reactive then compared to the halogen, because of their force, internuclear force. Now we will discuss the most of these properties and detailing of this introduction in next video. Thank you.